started saving them about a year ago. So 96, Tech Talk 96 means that I have been recording this for 96 weeks in a row. I've been doing this live, not recording, but I've been doing this live every Tuesday at 6 o'clock Eastern. And the reason I have information to share with you guys is I was blessed. I guess the good Lord gave me a little bit of a gift of gab, or I'm not embarrassed to talk to you in person because I'm just who I am. I'm just a 66-year-old guy that loves motorcycle drag racing, and I learned about engines all the years because I tore up a lot of stuff. Hey, Donald. Hey, John. Great to see your names on here. And you know, when I read your name, I see your face, and it's really cool. I don't get to see you in person like I did. Hey, Steve, but I get to see you on here. So, how do I know enough to tell you this stuff is over the years of 41 years at Star Racing in Americus, Georgia, we had 80 or 90 people come to work there, and we had several 100,000 clients and customers come through, and we were selling them horsepower. We sold them parts, we sold them how to go faster, we sold them engines, complete motorcycles, and we did it for years. I raced cars for my whole life. I raced Pro Mod when it first came out. I raced Pro Stock Car when it came out. Not when it came out. I was a young'un then. Bill Glidden and let's see, who was it? Bill Jenkins in 1970 with his Vega, and those guys. That was pretty new back then. But I was a fan. But anyway, when I raced a lot, and over the years I learned about racing engines, and what was neat about it was very important formula that we learned, and it's really kind of stupid. We didn't invent it, but it made a lot of sense to me. In order to finish first, you must first finish. So what we learned in racing was things that make the engine last longer and go faster. And over time, we were able to translate those things that made it go fast and last longer and put a version of that into street use. So then we had the highest echelon of performance that we could get, the most horsepower per cubic inch a man could make in engines, all the way down to I have to drive it all the way from Georgia to San Francisco for a wedding, and I'm going to drive it back, and I only got a week to go there, do the wedding, and a week to get back, and that's all I got, this motorcycle, and you just build the engine. So circle track, racing dirt, racing late model, racing asphalt track racing. We did so many V8s. We had about 20 V8s lined up in our shop one time, the blocks lined up to do boring and honing and balancing and valve jobs and main. We would align hone them and bore and hone torque plates. We had all the cool Sun and Rottler stuff. And anyway, we learned so much, and now I'm retired at 66, and I make a few parts and sell a few parts. I commission a few parts. I do a little bit of consulting work, but over the years I learned enough information to share it with you. And it is my opinion. It is what I think I know. It is what I think I have learned. And what's really great about doing this is when I tell you this and I talk to you these things, hey, Scott, you're right. Intake valve open. Intake valve closed. Ha ha. Intake valve closed. Just because you put IVO doesn't make it right. It's IVC. Pay attention now. I did not drag race snowmobiles because I don't like being cold. Hey, Rob, when it's cold, I go where the heat is. And when it's hot, I go where the cold is. So I'm a kind of a fair weather kind of guy. I like when it's 70 outside and a light breeze at my back and blue skies and a little cloud so I don't get sunburned on this coconut. All right. Anyway, so these valves, over time, we learned a lot. When we started, there were some cars out there. Our Super Cobra Jet had like a 30-degree angle on the valve job and on the valve and on the head, and then most everything was a 45-degree when we started. And I was telling a friend on the phone today about even the Chrysler Hemis way back when. They were opposing valves, and they had a lot of overlap between the intake valve opening and the exhaust valve closing. There was a lot of time where both valves were open in the combustion chamber, so a lot of flow would go right through the head, which wouldn't do anything. But in their mind, back in the day, they thought that the exhaust was scavenging through the crossover when the piston's near the top, both valves are open, and it would actually hook a trailer hitch to the intake and charge and pull it in. And right when it was starting to go out the exhaust pipe, they would slam the exhaust valve shut and then really jam the intake open as the piston goes down on the intake stroke. And I know we could walk through that several times, and I have, but slowly but surely over time, we have made the cylinder heads better. We've made more air move through the engine, and we have slowly but surely used up that overlap. We have the valves less open at TDC now. Instead of having 80 degrees of rotation where both valves are open, getting down in the 40s. The fastest pro stock motorcycles now run really close to 40 degrees overlap at 50. Pro stock cars are probably in the 50s or 60s on overlap now. That's a guess. And because the better the engines run, the less overlap we need. And that means at the end of the day, the better the cylinder head is, the less cam timing you need. So you can use only the 720 degrees you have of the intake stroke, the compression stroke, the power stroke, and the exhaust stroke. That's 720 degrees. You get to use some of those degrees for other work rather than having the valve open all the time. I mean, when we first started, man, we ran pro stock car in 92, 93, 94, I believe. We were helping Gary Brown, and the camshafts that were in those engines had so much overlap that if you did the duration from 5 thou lift all the way through to 5 thou close, the duration, the valves were open all the time. If you took the intake and exhaust and you figured out the duration on the intake was about, what was it? It was about 360 degrees duration on the intake and about 360 degrees duration on the exhaust. And they weren't at two different times, so it wasn't a full 720, but they were overlaid on top of each other, so there was a very little work doing doing the power stroke, and there was very little work doing the compression stroke. So it was hard to make the engines run better as long as that was the case. Today, I was going to tell you about valve jobs and valve shapes. I had a guy last week ask me if I would talk about valve shapes. Hey, Graham. I mentioned Graham this weekend talking about we had the first Corvette LT5. It was 1990. ZR1 had the Graham helped on the design team over in England to come up with that engine, and the engines were built by Mercury or Mercury Marine over in, I think it was Oklahoma, and then Chevrolet put them in the cars in Bowling Green, Kentucky in 1990, and there were only a few ZR1s sold. They got down to like 400 or 440 of them a year or something like that. They were sold for about 5 or 6 years. But what was neat about it was they had 4 different camshafts. They had an intake cam on the driver's side, and they had an exhaust cam on the driver's side. They had an intake cam on the passenger side, and they had an exhaust cam on the passenger side. So that was 4 camshafts, okay? So they had the driver's side and the passenger side. And people were all thinking about lobe centers and lobe separation angles. It was really tough when you got 4 camshafts, and each one of them's on adjustable sprockets, and it really make you spin out and get a headache. I saw Graham on there, made me think of that. Hey, David, long time no see. David's been in there, man. You've been messing around with some overlap and some duration and all that stuff forever. But the valve shape, this is a combination of what's happened to us through evolution and history. We found out that the valves were very important what they weigh. And we also found out that it's very important how stiff they are. And if you get one that's light enough to where the camshaft and the lifter profile can control the valve all the way off the seat and all the way back on the seat at maximum RPM, found out that the valve would bend. It would. You guys are not old enough to know what an oil can is, but we used to have these oil cans that was shaped like this, and it had a spout, and we would want to put oil on something. We would take the bottom and we go dunk 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 dunk, and the valve was actually oil canning, where the stem, when it would come back to the seat, the valve would come up and it would hit the seat, and the retainer and the spring and the keepers would keep going, and it would pull the valve like it was rubber, and then when it would go back and rebound, the stem would come back through and jump the valve back off the seat. So the thing was oil canning right in here. So we had to make the valve stiffer, and we didn't know this because there was no spintrons. A spintron is a really cool machine that the high-end race teams have access to, where they have a 75 horse or 100 horsepower electric motor that has a blower belt drive to a drive shaft that you hook your engine to, and you can put the valves and the heads and the cam, push rods, rock arms on it, and a solid shaft to drive the timing chain or the timing gears or the timing belt, so that you could watch with a laser and a camera and a I guess it would be a laser and a camera, yeah, and be able to see the valve and actually measure the valve movement on and off the seat at every RPM. You just turn the knob and it goes, and when you got 16 valves going up and down, and you got 16 lifters clanging on a camshaft, and you got the rock arms and the push rods jacking up and down, it makes a lot of noise. It almost sounds like a V8 running with no pistons in it. But what we learned was the deformation or the deforming of the intake valve and the exhaust valve. So we decided to we're talking about pro stock. NASCAR guys and pro stock guys would start changing the shape of these in order to get them to quit deforming. But as we put enough mass and enough strength in the valves, going to titanium, going to different alloys of titanium, different alloys of aluminum and titanium, which is some crazy, pretty far out there stuff. The rules, the sanctioning body said, you know what, we need to put limits on this crazy spending. The teams that have the money and the wherewithal, the ones that could generate, that have the resources, the imagination, and the abilities, and the equipment, and the manpower to actually test and refine parts. So there were some high-end teams that were running unobtainium valves. They were running parts that were shaped like different than everybody else's. There was rumors going around that there was all kind of beryllium and all these high-end materials that were hard to buy, hard to pay for, and had to be replaced often. And it didn't seem fair. It's a lot like our democracy, you know, the ones that work really hard and spend the most money. I don't know the name of it. I'm not going to get in that debate, but they always have to take care of the ones that don't have the ability to do that. My daddy raised me to think that I just needed to work harder and be more resourceful and have better imagination to figure out how to do it. But when I had the big sponsorship deal where my job was only to win, I was able to try this stuff too. But going back to NASCAR and pro stock car, for instance, setting the performance bar. The committees, the sanctioning bodies came in and changed the rules to where it would be fair for the little guys and take away a little bit from the top and add it to the bottom. And that's good in a way. Maybe it helped equalize the racing a little bit, but now, if you go and look at the pro stock rules, now it's almost like all the engines are the same. You can put the same engine in every car now. All of them are 500 cubic inches. They all have almost the same block. They all have almost the same heads. You can put a Chevy motor in a Ford. You can put a Ford motor in a Chevy, but nobody's running one. They're all Camaros with Camaro 500-inch engines in them. And they're like giant NASCAR engines where all the money was spent over time to get the camshaft high enough to get the camshaft. The camshaft core is bigger than the crank core. Back when I was racing as a kid, I remember the crankshaft bore was this big and the camshaft bore was this big, but on the Spintron and on the racetrack, they found out that the camshafts are doing this, and the lobe phasing is changing because they got all the lobes on one stick. Therefore, lobe separation angles. So the camshaft was a torsion bar with 16 lobes on it, and they figured if they could make them bigger and bigger and bigger in core, that they would deflate. It says I'm trying to reconnect. Golly, I thought I had good access today. But anyway, now they've changed the rules to where almost everybody's the same. NASCAR is really getting bad where everybody's the same. It's pretty good that now it's the guy that drives the best, the guy's got the car set up the best, and the guy with the most luck. But listen, you and me, we're not governed by those rules. We are still trying to figure out how to make more horsepower. We're trying to figure out how to go faster. And one thing that we found in our career is there is a trade-off in all the parts. The pistons, the valves, everything is a trade-off because we want it to be stiff enough to stay sealed when it's time to seal, and we want it to be strong enough to last, because in order to finish first, you must first finish. And the 600-mile race this weekend, I noticed there were only a couple of cars went out, and they had the same problem. I understood they were the same engines as everybody had in the GM camps, but they must have had a different drive. This is an assumption on my part. They had a different power steering and oil pump drive, and they both had belts fail. So there's somebody out there watching this right now that knows what I'm talking about, and they know the answer, but it's not public knowledge right now because somebody's job is counting on that. Now, I'm going to move over to the table so I can draw a little bit, but I wanted to talk to you in person first. All right, let's move to the table, and let's change over the screen. Stick with me, because I'm not going anywhere. What we found out, you guys. I also have on here where you can reference this as Tech Talk number 96. All right, you guys on? Everybody's here? Okay. This is a big piston for a Milwaukee 8 Harley, and I wanted you to see is, since it's ½ inch bigger than the stock piston, there's room for a really big valve. So you can put big valves in it, and look how far away it would be from the cylinder. I don't know if you can see it from that angle. But if you put this big a valve in a Milwaukee 8 or any Chevrolet, Ford, Chrysler, all different engines, Kawasaki, Hayabusas, whatever, you put this big a valve in. A stock one was 40 millimeters. This one's 42.5, and we put 45 millimeter over 5 millimeter over valves in these. But the limit on these, you guys, the valve size limit is the bore. And I have a marker that will definitely show me that. I gotta find it. Here it is. We have the valves in the head, this 4-valve. There's 2 intake valves. All right. And here's the combustion chamber that it sits in. Let's see how I can draw that. And here's the head. And here is the bore. This is cylinder wall. Now, if you put, this is 4.5 bore that we have on our Milwaukee 8. Y'all see that okay? Now, if we took this and went down to a 4-inch bore, that means we got to move this cylinder wall over 1/4 inch, and we got to move this cylinder wall over 1/4 inch, and now the chamber lines up back with the bore like it did stock. But look, the valves are so close. And if you put the piston back in the picture, the valve is going to be so big and the bore is going to be so small. The bore goes this way 1/4 inch. And this will go into the valve pocket, and now your valve is going to be too big. So the bigger the bore, the bigger valve will fit. Now there's another limitation on valve size, and it is the clipping clearance. On a stock Milwaukee 8, they're 40 millimeters each. So they're little. They don't get near each other, and they're not close to the cylinder wall. But they flow enough air to make 100 horsepower. There's guys out there right now that are putting cams, ported heads, pipes, air cleaners, bigger pistons, better cams, and they're getting 140 horsepower out of stock heads. The only reason they can do that is because a stock Milwaukee 8 head is 4-valve, and it flows more air than any twin cam head except for racing twin cam heads. Milwaukee 8, and I got that one dried out, so let's move to a more wet one. There we go. There's the bore. There's 2 intake valves and 2 exhaust valves. These 4 valves flow more than the same bore size in a twin cam that has only 2 valves. These are bigger, but there's more air moving through the engine because there's 4 of them, 2 intakes and 2 exhausts, and they open more area to the cylinder sooner in the lift curve, and that make more horsepower and allows us to run less of a camshaft. And when I say less, it's less lift and it's less duration. That means time the valve is open. Ben Strader said that he found through his years of experience, and I have too, but he said it last week, that a good 2-valve engine, which has 1 intake valve and 1 exhaust valve, a good one, almost all the good ones have almost the same duration camshaft. At 50 lift, 50 off the seat, 50 from closing to the seat, they all have between 260, 270 duration. They're all within about 10 degrees. Yes, there are some guys that need more than 270 degrees at 50. There's some guys that can get away with less than 260 degrees at 50. But it's amazing that if it is a 100 cubic inch engine or a 900 cubic inch engine, they're still really close. So what's interesting about that is There is just that number that matters. But as the cubic inches get bigger, we have to run more lift, we have to run bigger valves, and we will always put the biggest valve that will fit. And if a valve is too big for some guys, which when a guy says, hey, when a guy walks up to me and said, hey man, my heads flow too much, I'm like, okay, what's the alternative for you? You need heads that flow less? No, I have never had one that flows too much. If it does, I change the camshaft to suit. I've had a head too big for a carburetor. I've had a head so big in port volume and dimensions that it was lazy down low, but it will make enough velocity if you rev it high enough, because velocity comes from how fast the piston goes up and down, not from the flow bench. Guys that live their life and build everything they know based around a flow bench that says you got to have 300 feet per second, you got to have 400 feet per second at 28 inches and this and this and this. I'm telling you, the engine doesn't know that guy. Yes, that guy that knows that stuff, that guy that tells you that, the guy that writes on the internet about the velocity and the heads have to work on velocity, most of that information, this is my opinions again, most of that stuff came from a great man that worked at Superflow, that wrote a book about how to make a flow bench work, how to use a flow bench. And it taught us a lot. It taught us the basics, but it's not the Bible of how you make 3.5 horsepower per inch or 3 horsepower per cubic inch or what's coming next, 4 horsepower cubic inch. Those are basic numbers based around old technology, because there were no fuel injected engines when that boat was written. The ports were developed to go around push rods. The ports were developed to make carburetors meter fuel and air, which is different nowadays, you guys. With the Milwaukee 8, we can put injectors in and spray the gasoline right on the valve, and if the air is going slow or the air is going fast, you can still get the right air-fuel ratio with a laptop and an ECM or an ECU and tell it how much fuel to spray on it, despite what we used to see back in the day. We used to have so much velocity that it would be our opinion that the air would turn into the engine and the fuel would centrifuge out and wash the walls down. Or the velocity was so slow that the fuel would fall out of the suspension and it would puddle around on the piston and detonate and cause spark knock and all kinds of things. But those are really, my opinion, we're just past that, you guys. We are past that, because now we can get the air-fuel ratio we want at every RPM. We can get cam timing we want at every RPM. We have variable duration camshafts. They'll move some, but they don't move everything. But there's a lot of ways now to make more power over a wider range. But if you're in the same business I'm in, or you have the same passion I do, I want to make more horsepower than the other guy. I want to outrun the guy with my car. I want to outrun the guy with my truck. I want to outrun the guy on the motorcycle. I want the fastest. I want the most power. And I love to do it normally aspirated. I am all about, yes, I love blowers. I love screw blowers. I love superchargers. I love rotochargers. I love magna chargers. I love boost. I love boost. Everybody needs some boost. But my purpose on the earth, I think, is try to squeeze the most power out of a cubic inch of an engine based on airflow and control of the fuel and air into and out of the engine. And I've learned a little bit about it. Now, I'm going to show you a picture of what went through before NHRA and NASCAR took over some of the rules. This is an opinion. So we had to have a stiff valve. Well, the stiffest shape we can make is a triangle. And the guys, to get the weight right, they were running these nail head valves where they would have an 11-degree back angle on the valve right here. And that was to make it really, really light. Then they would start hollowing this out to make a dish, and the valve would bend here and bend here, so this valve would go like this when it was running. But you couldn't tell it unless you put it on a spintron and actually watched the scope from the laser and the camera. And what is that? That light, strobe light. The strobe light, the laser, and the camera, to measure all that stuff, to see the valve deforming. So the taller you can make this back angle, and the more flat you can make this chamber side, the stiffer the valve was, and therefore you could make more power at higher RPM because you were not deflecting the valve, was not folding up. You ever put a wine cork into a bottle? It wedges itself in there. these valves, these nail heads, would fold up like a lawn chair and fall into the port. And you could see these valve jobs would have a smeared look. Instead of it wearing around the valve, they were wearing this way. You could see the wear, where the valve was actually sucking into the head and coming back out, sucking in the head and coming back out. How long do you think this head will stay on this stem at that RPM where this valve is wedging in and out of the hole? And it's wiping the valve job. It's wiping the seat angle. It's wiping the angle on the valve. So they came up with this really cool idea. I didn't invent it, but I learned about it. This triangle-shaped valve. And that thing is so heavy, so they made them hollow. Now it weighs the same, but it's so weak through here, it would start wiping the seats again. Another thing we found out, if you put this on the exhaust side, it would flow really good on a flow bench at 28 inches or 20 inches or whatever your flow bench will do. But I'm going to tell you something, it lost 50, 40 horsepower on a V8 because all the area that we need for the exhaust to blow out at exactly at the time it needs to was stopped up with this. Air can't get by that. Sorry, it will on a flow bench. When you got the flow bench on and you're flowing in at 10 inches of depression or 20 inches of depression, this thing turns around here so pretty and the flow number goes off the chart. But when you're running this thing at maximum RPM, down the racetrack, 10,000 RPM, this exhaust was trying to get out of here with that same shape, and the head's shaped like this. The head, the port was shaped like that. There's nowhere for the air to go. It can't get around here. So you put it back on the flow bench and turn it down to 25 inches or 20 inches of depression. It would turn so pretty. Turn so pretty. But in reality, it was putting a cork in the bottle. How do they run such a big, giant triangle-shaped valve? Well, first of all, they'd cut a big disc out in here, and they would hollow all this out. And they would drill a hole, rifle drill, right through the stem. And they would hollow all this out, and then they would weld the disc back on. So they would cut this face off, go in and gut all the materials out, and thin it up and make it light and hollow. And then they would put the disc back on and laser weld the disc back on. Now you have a hollow triangle-shaped valve that would weigh less than this valve, and it would hold shape perfectly because it could not deflect with this much cross section. There was no deflection. Now this is an exaggerated version. It didn't look exactly like a perfect isosceles triangle, but it sure looked better than this nail head. People at flow benches hate nail heads because the air does not want to make that turn. The air wants to turn like this. That's why people love valves that look like that. And then they put a 3-angle valve job on here because on the flow bench, these numbers change shapes. These angles change the flow numbers. And I told you the engine doesn't know that guy. There's not an engine. Let me say this again because I'll get myself in trouble and they'll be chasing me with pitchforks and torches. But the guys that really, really do good with flow benches and the guys that bank on their flow bench, they go fast. They set records. But that doesn't mean it's the best it could be. There's also guys out there that haven't even turned their flow bench on for a year, 2 years, that are setting records and winning races because they got a better grasp of what's really going on inside. I just noticed my clock and my time ran out. I didn't get time to tell you a good story today, but Tech Talk 96 is in the books. I flopped around like a fish out of water. I ran my mouth without thinking, and hope you'll forgive me for that and tune in, and I'll try and do a better job next Tuesday. But God bless y'all, and please look after each other because we're all we got. And I hope you had a enjoyable Memorial Day weekend because of the sacrifice of many that made the most sacrifice of all by giving all of themselves for us to have the life we have today. And it's not about race or religion. It's about sacrifice and the people that gave everything. And I'm thankful for them, and I hope you are too. May God bless y'all. Amen. Good night.